Good evening, class. We are looking at chapter 1 review, functions and models. So in this chapter, which is a review, the following is covered. Chapter 1 called functions and models, 4 ways to represent a function, mathematical models, new functions from old ones, exponential functions, inverse, and logarithmic functions. All right, so let's look at the methodology by which we represent a function. We can do it 4 ways: verbally by a description in words, numerically by a table of values, visually by a graph, algebraically by an explicit formula. So we have the function machine. X is the input, F is the machine, if you will, and the output f of x. So we have the pair x comma y, f of x is the y, such that x is an element of D. This is read an element of D is the domain. So in set theory, everybody remembers that. It's read an element of. The VLT, vertical line test. A curve in the xy plane is the graph of a function of x if and only if no vertical line intersects the curve more than once. A function f is called increasing on an interval if f of x sub 1 less than f of x sub 2 results in x sub 1 less than x sub 2. And it is called decreasing if f of x sub 1 larger than f of x sub 2, x sub 1 is less than x sub 2. In short, in this case, increasing means x gets larger, so does y. Decreasing means when x gets larger, y gets smaller. That's a simple way of looking at it. I need to erase that part. HLT versus VLT, horizontal line test. If a horizontal line can be drawn so that it intersects the graph of a function at more than one point, the graph is not one-to-one. No horizontal line can intersect the graph more than once. For any one-to-one function, f of x and its inverse, f inverse of x, this is how it's read. Their composite function is x. F of f inverse of x is x, f inverse o f of x is x. In this case, x is in the domain of f inverse. In this case, x is in the domain of f. F of f inverse, if f inverse o f of x. When we say even function, that means f of minus x is f of x. It's symmetric with respect to y-axis. When we say odd function, f of minus x is minus f of x. That means symmetric with respect to the origin. So let's look at some examples here. We want to find the domain of a function, any rational function. You set the denominator equal to 0 and you exclude it. If you set x plus 2 equal to 0, x becomes negative 2, so x can't be negative 2. That's one way to write it. But a more proper way would be the interval notation. Minus infinity, negative 2 union negative 2 to infinity. We are excluding negative 2 by using parentheses. What about this one? Again, we are dealing with a rational function. We are going to set the denominator equal to 0. To do so, we are going to do the factoring. We want two numbers. The product is negative 10. The sum is positive 3. So that would be positive 5 and negative 2, which means if you look at this one, x can't be negative 5. If you look at this one, x can't be 2. In other words, set each one equal to 0 and exclude it. And that's fine. Now, how do we write it in an interval format? From negative infinity to the smaller number -5 union -5 to 2 union 2 to infinity. This would be the interval format. Is f of x equals x squared minus 4 over x plus 2 equal to x minus 3? Let's see the difference between the two. Remember, in order to graph a rational function, the first step is to simplify it if possible, put it in its lowest step. And also remember, to find the vertical asymptote, you can set the denominator equal to 0. However, not if it's not in its lowest term. The top is a squared minus b squared. A minus b plus b. And then x minus 2, x plus 2, and x plus 2 cancel each other. So is it equal to x minus 2? No. It is equal to x minus 2 for all values of x, except x can't be negative 2, because the domain of the original function remains intact. So what is the difference? If we were to graph this, would be a line, okay? 0 minus 2, 2, 0. If we were to graph this one at x equals negative 2, creates a hole, negative 2, you plug it in, and so you know where the hole is. If you plug it into this one, you get a hole at negative 2, comma, negative 4. Over here. So this rational function is the line with a hole, whereas this one, y equals x minus 2, is simply a line, a continuous function. So we're going to distinguish between the two. So y equals x minus 2. Determine whether each of the following function is even, odd, or neither, and reminding you the meaning of those. So basically, you evaluate f of minus x. So if I replace the x with minus x, this is minus x to the power of 5, becomes negative because the exponent is odd. This is minus x. And it's the same as minus of the original function, or the opposite of the original function, or minus f of x. And therefore, it's an odd function. It's an odd function. We do the same thing here. We evaluate g of minus x. 1 minus negative x to the power of 4 is the same as x to the power of 4. And it's equal to g of x. So it makes it an even function. Now let's look at this one. Let's look at h of minus x. So this is 2 times minus x. That means minus 2x. This is minus negative x squared is itself minus x squared. And as you can see, they are not equal. They are not opposite. So it's neither nor. Therefore, since h of minus x is not equal to h of x, and h of minus x is not equal to minus h of x, we conclude that h is neither even nor odd. Given a graph, where is the function increasing, decreasing, and constant? Well, one easy way to look at it, if you assume it's a line, for example, you see it goes this way, that's decreasing, this way, that is increasing, this is the horizontal line, it's a constant, that's the constant. So it's increasing there from here to here, from negative 4 to 4, from negative 4 to 0. The way you write it, you can say x is between negative 4 and 0, or you can say parentheses minus 4, 0. The endpoints are not included in general when you are writing increasing, decreasing. Where is the function decreasing? Here as well as here. Here between -6 and -4, so parentheses -6 -4. Here's between 3, 1, 2, 3. And 6, that means union 3, comma 6. Where is it constant? Wherever you see a horizontal line from 0 to 3. As dry air moves upward, it expands and cools. If the ground temperature is 20 degrees Celsius and the temperature at a height of 1 kilometer is 10 degrees Celsius, express the temperature T in degrees Celsius as a function of the height H in kilometers. Assuming that a linear model is appropriate, draw the graph of the function. What does this slope represent? And so on. So we are looking at the height and we are looking at the temperature, and the height is the independent variable. Temperature depends on that. Okay. Temperature as a function of height. Therefore, we're going to write, normally we have X and Y. Now we have H and T. Ground 20 degrees, that means 0, 20 degrees, 1 kilometer, 10 degrees, 1. And normally we have y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Rise over run is the slope. Therefore, t sub 2 minus t sub 1 over h sub 2 minus h sub 1. So I'm going to write what we are used to. And now the one that we're going to use is 10 minus 20 over 1 minus 0. And obviously we get -10. And that would be units of the numerator, temperature, over the units of the denominator in kilometers. So -10 degrees Celsius per kilometer. That's the meaning of it. And because this one is given, this is the y-intercept. And now we are going to say the t-intercept. Y equals mx plus b. So we are going to use t equals -10 instead of xh plus 20. So again, this would be the y-intercept. Now it's the t-intercept. So you can plot those two pairs, or we already have the y-intercept, or specifically the t-intercept. Now the x-intercept or the h-intercept, if you set t equal to 0, h becomes 2, and we can graph it. And t is a function of h, and we don't go to the left side of it. Don't go negative. All right, now the slope is m equals -10 degrees Celsius per kilometer. It represents the rate of change of temperature with respect to height. So as we add 1 unit to the height, 1 unit of what? 1 kilometer. Then it drops by 10 degrees Celsius. That's the meaning of it. The average rate of change of y with respect to x is the average rate of change of temperature with respect to height. What is the temperature at a height of 2.5 kilometers? So right here, replace the h with 2.5. We get -25 plus 20 is -5 degrees Celsius. So pretty straightforward, everybody. A linear function. New functions from old ones. Translation or transformation, and we are assuming C is larger than 0. So if you have y equals f of x here, so f of x plus c takes it up by c units, f of x minus c brings it down by c units, f of parentheses x plus c takes it to the left by c units, f of x minus c brings it to the right by c units. And again, y equals f of x. Again, in this case, c is larger than 1. So y equals c, if we multiply by f of x, in essence, we're multiplying by the y, and it makes it larger along the y-axis, and 1 over c makes it smaller along the y-axis. If we go with minus f of x, it flips over with respect to the x. If we go with f of minus x, the function flips over with respect to the y-axis. Algebra functions. The operations that we do with numbers, we can do with functions. F plus minus g of x is f of x plus minus g of x. That's the sum function or the difference function. Fg is f of x times g of x. F over g is f of x over g of x. Needless to say, as always, the denominator can never be 0. If you happen to have a domain for f of x as well as g of x, for f of x, let's say it's A. For g, let's say it's B. Then the domain for all of them is the intersection of the two. The domain for all of this, the intersection of the B, A and B. Now this one has a restriction also. So in this last case, the domain of f over g is x, and then is an element of the intersection. This, by the way, this is the intersection, A intersection B, such that g can't be 0. Composite function, the definition, f of g is f of g of x, g of f is g of f of x. So just some of this stuff reminding you of operations on algebra functions and composite functions. So transformation of functions, absolute value function. If y is absolute value of f of x and absolute value of f of x, first of all, absolute value of x by definition is x if x is larger than or equal to 0. Minus x if x is less than 0. Now, if y is absolute value of f of x, then absolute value of x becomes the same function if f of x is positive or 0. And it negates that minus f of x, just as it does with this one, if f of x is less than 0. What does it mean? If you were to sketch this, first and foremost, ignore the absolute value and graph this. Y equals x squared minus 25 is a parabola. Y equals x squared is a parabola at 0, 0. It goes down by 25. So looks like this. This one is 0 to 0, negative 25. Let me. Okay. Parabola is here for y equals x squared. X squared minus 25 goes down by 20. Okay. But that's not what we want. We want this one. So what does it say? There is a portion that is positive. Don't change it. If you look at the blue piece, it's above the x-axis. Doesn't change. If you look at the yellow one, it's below the x-axis. It's negative. Therefore, what it says, it flip it over. So this one, just flip it over. So the part of the graph of f of x that lies above the x-axis remains the same. The part that lies below the x-axis is reflected about the x-axis. So for the absolute value, this blue portion remains and the yellow flips over. That's the idea. We want to sketch y equals absolute value of square root of x minus. Well, we're going to do the transformation, and we're going to start with, of course, the basic elementary function. There are many functions that are elementary. One of them is y equals square root of x, and we should know the graph of y equals square root of x. I'm assuming the elementary functions Y equals x squared, y equals x cubed, y equals cube root of x, and so on and so forth. We know the graph. So that's square root of x. Now, square root of x minus 1 is the same graph, but now it goes down by 1 unit. In other words, this is 0, 0. This goes down to 0, -1. So we have this one. Now it goes down. And for the absolute value, this portion, let me use a different color. This portion, everybody, is above the x-axis. So this portion remains unchanged. This is negative, it's below. So it flips over like that. So that's the graph. So a quick recap. Let me erase my work. You should know the graph of square root of x, y equals square root of x, an elementary function. Square root of x minus 1 brings it down by 1 unit. Now, because we want the absolute value, the portion above doesn't change. The portion below, just flip it over with respect to the x-axis. We want to find the domain, square root of x. Simply put, x must be greater than or equal to 0. That means from 0 to infinity, 0 is included. That's why we could use bracket for 0. Infinity and negative infinity are concepts, so we always use brackets for them, always without exception, okay? G of x, 2 minus x, greater than or equal to 0. Two greater than or equal to x, or x is less than or equal to 2. That means from negative infinity to 2, and 2 is included. We want to look at these two functions, f plus g of x is square root of x plus square root of 2 minus x, and f over g of x, square root of x over square root of 2 minus x. We want to look at those functions as well and figure out what the domain is. So for this one, the domain is simply A intersection B. This is A, this is B. For this one is A intersection B, and whatever makes the G, the denominator, 0 is out. So A intersection B, what is in common from here to here? So maybe graphing will help. So let me quickly show you. So what we have here for the first one starts from 0 and it goes to the right. So that's this one. For the blue one, from negative infinity, so this is 1, this is 2, this is 3, so this is 2. So for the blue one, starts from 2, and 2 is included, and it goes, so this is negative, this is positive infinity. So it's very simple to see that the red and blue come together from 0 to 2. So that's their intersection. Intersection means what's in common. If we were interested in the union, would be negative to positive infinity. So from 0 to 2. Now, what's the answer here? It's the same thing, but g of x, the denominator, cannot be 0. So we go back to this one, and this is 0 when x is 2. So all you have to do, get rid of 2. How do you get rid of 2? Parentheses. So 0, so this was bracket 0, 2 bracket. This will be bracket 0, comma 2 parentheses. That's it. Okay. So I hope everybody is fine with that. Okay, I'm going to erase my work and I'm going to move on. All right, f of x is square root of x minus 3, g of x is x squared, h of x is x cubed plus 6, and we want to find f of g o h. Okay. By the way, before we move on, I want to quickly just remind you that if you look at what we had here, there is no index here. There is no index here. The index is 2. When the index is even, we have a restriction. When it's odd, for example, y equals cube root of x, there is no restrictions. Okay, the domain is all real numbers from negative to positive infinity in any way. So there are a couple of ways to do this. We can find f of g first, which is f of g of x. That means use the function f of x and replace the x with g, which is x squared. And now f of g o h, that means use the f of g function and replace the x with the h function, which is x cubed plus 6, and you're done. Or you can find GOH first. GOH is g of h of x. And that means go to the g function and replace the x with h. So x squared, x is replaced with x cubed plus 6, and then quantity squared. And now FOGOH, go to this function and replace the x with this. And of course, the same as we got here. So either way, you come up with the same answer, everybody. Exponential functions. F of x is in the form of b to the power of x. B must be positive and can't be 1. When b is larger than 1, looks like this. It's an exponential growth. Examples, y equals e to the power of x, y equals 10 to the power of x. When b is between 0 and 1, it's an exponential decay. And if it's 1, it's not an exponential function because 1 to the power of x is just 1, and that's a horizontal line. So what do we notice? Horizontal asymptote. Both of them have the horizontal asymptote, which is the x-axis with the equation y equals 0. They don't have a vertical asymptote. Y-intercept at 0, 1 in both cases. There is no x-intercept. Domain is all real numbers, range from 0 to infinity. What's the difference? Increasing, decreasing. So when b is larger than 1, it's an increasing function. The limit of f of x as x approaches infinity. That means the first quadrant. That means we're talking about the end behavior of the function. I hope you remember that from pre-calculus. Whereas the limit of f of x as x approaches minus infinity is 0 gives rise to the horizontal asymptote, the x-axis with the equation y equals 0. When b is between 0 and 1, it's a decreasing function. Limit of f of x as x approaches infinity is 0 gives rise to the horizontal asymptote. Limit of f of x as x approaches minus infinity is infinity. That's one of the end behavior, referring to the second quadrant. Now, let's look at what we have here. Those are exponential properties. Zero exponential, a to the power of 0 is 1. Product rule, a to the power of m, a to the power of n is a to the power of m plus n. Quotient rule, a to the power of m over a to the power of n is a to the power of m minus n. If you have a over b, each one gets raised up. Negative exponential rule, a to the power minus n is 1 over a to the power of n. 1 over a to the power minus n is a to the power of n, meaning just move it. And if you have a over b to the power minus n, make it b over a to the power of n. And of course, the power rule, a to the power of m to the power of n times is a to the power of m times n. So pretty straightforward. I hope everybody is fine with that. We are going to move on. Just wanted to remind you of the exponential functions and some properties that everybody has seen, and you really should have an easy time with that. We want to sketch the graph of the function y equals 1/2 e to the power minus x minus 1 and come up with the domain and range. So obviously, we're going to start with the function. We should know the graph. It's one of those elementary functions, essential functions. Y is e to the power of x, looking like that. The next one is e to the power of minus x. So how do we go from e to the power of x to e to the power of minus x? X becomes minus x. Think about it. So it's reflection with respect to the y-axis. So reflect the graph of y equals e to the power of x about the y-axis, y equals e to the power of minus x, and it looks like that. The next one is to use the 1/2. So what happens, the y coordinate gets smaller, so y equals 1/2 e to the power minus x. Compress the graph vertically by a factor of 2, y equals 1/2 e to the power minus x. Okay, so for the sake of argument, 0, 1, 0, 1 goes to 0, 1/2. So you see that, okay? I hope everybody is fine with that. Very straightforward, everybody. Finally, -1. So the same function goes down by 1 unit. So shift the graph down by 1 unit to get to this. When you shift it down 0, 1/2 becomes 0, -1/2. So this one is now located at 0, -1/2 as an example. So I hope everybody can see that. It's pretty straightforward, everybody. Now, here's the final answer. So we want the domain and range. Domain, if you look at this one, all real numbers, all real numbers, all real numbers, all real numbers. By domain, we mean try to lay down the graph along the x-axis. What does it cover? That becomes your domain. So the domain is all real numbers, everybody. Okay? The domain, therefore, is all real numbers. What is the range? Let's go back here. 0 to infinity, 0 to infinity, 0 to infinity. What about here? Y equals -1 is our new asymptote, the horizontal asymptote. So from -1 to infinity, needless to say, -1 is not included. So I hope everybody's comfortable with the concept. And we want to come up with the domain. G of t is the square root of 10 to the power of t minus 100. We are dealing with the square root. The index is even, so what's underneath must be greater than or equal to 0. 10 to the power of t minus 100 must be greater than or equal to 0. That means we take this one, make it 100. And as you know, 100 is the same as 10 squared. Therefore, t must be greater than or equal to 2. So that's pretty straightforward. What about this one? As you know, let's say it's sine of x. Just first, let's do that. Let's assume it's x. As you know, sine, the domain is all real numbers. So if by any chance there's any restriction here, that means e to the power of t minus 1, does it have any restriction? Then you apply it. But as you know, the domain of sine x is all real numbers. The domain of e to the power of t minus 1 is also all real numbers. So the domain is all real numbers. So it's pretty straightforward. I hope everybody is following that. All right, we want to solve this equation. E to the power of x squared times e to the power of 2x plus 1 is e to the power of t. Again, reminding you of what we had here, okay, those exponential rules. We're going to go with the product rule, and we're going to add these two. And because both sides have the same base, they must have the same exponent. So x squared plus 2x plus 1 must be equal to t. It's very straightforward, everybody. Find the inverse function where f of x is given as 4x minus 1 over 2x plus 3. What are the steps? Number one, change f of x to y because it's easier to work with. That's the only reason. Reminding you how to find an inverse function, everybody. Interchange x and y. So this becomes x, these two become y. And right here you have the inverse. However, we always solve for y, and that's what we are going to do by the cross product. Two xy plus 3x equals 4y minus 1. So we move the negative 1 becomes 3x plus 1. We move the 2xy becomes negative. On the right side, I can take the 2y out, but I'm interested in the y, so that works out. And I get 4 minus 2x. So all I have to do divide by 4 minus 2x, and that's 1. By the way, if there is a common factor of 2 between the top and the bottom, you have to drop it. It's not. You're done. You just give it the name F inverse. Now, did we come up with the correct answer? We know that their composite function must be x, and so f of f inverse equals f inverse of f equals x. So we're going to look at one of them. So for example, if we want to look at f of f inverse, replace the x with the blue function f inverse. Now, you're dealing with a complex fraction. The fastest and easiest way to simplify a complex fraction is to multiply by LCD, which is 4 minus 2x. So let's multiply the top and the bottom by that. So what happens? If you multiply these two, 4 minus 2x goes away, becomes 4 times 3x plus 1. And if you multiply this one, this 2 is minus 1 times 4 minus 2x. These two, 4 minus 2x goes away. 2 times 3x plus 1, and this one plus 3 times 4 minus 2x. So I hope everybody is comfortable with complex fractions. So all we have to do is simplify, and we are home free. So 4 times 3, 12x, plus 4, minus 4, plus 2x, 6x, plus 2, plus 12, minus 6x. So in the numerator, you have 14x. In the denominator, you have 14. Therefore, the final answer is x, and it checks. And I highly recommend for practice, you guys try the next one, F inverse OF, just for practice. Logs. Let's remind everybody what we know about them. If b is larger than 0 and b is not equal to 1, y equals log x base b is equivalent to x equals b to the power of y, x equals b to the power of y, y equals log x base b. As you can see, they have the same exponent, they have the same base. The base is the base of the log. So one easy way to understand it, if you follow this arrow, b to the power of y is x, so you can go from logarithmic format to exponential format and vice versa. If you can make it from here to here and vice versa in no time, you have no problem with any of the properties that you should know. So if you have a general log, y equals log x base b, that means b to the power y equals x. Log 1 base b is 0. That means log 1, regardless of the base, is 0. Log b base b is 1. Log b to the power of x of base b is equal to x. B to the power of log x base b is x. This is the product rule, quotient rule, power rule. Now, one thing I want to quickly show you, I hope you see this arrow. B to the power of 0 is 1. B to the power of 1 is b. B to the power of x is x, and so forth. And these two refer to the fact that logarithmic functions and exponential functions are inverse functions. Now, if we go to common log, y equals log x, we don't write the base. I write the base here just to make a point of it. You never write the base for common log. The base is 10. And then we can easily see the transition from general to a more specific case. Basically, log 1 drop the base. What about this one? It says if the base and the argument are the same. Log has the base 10, so it must be 10, and so on and so forth. What about natural log? The base is e, y equals ln x means log x base b. That's the meaning of it. We don't write it in this format. We have it in this format, and e to the power of y equals x. And these are the properties we should know. ln 1 is 0, ln e. Remember, when we write ln, the base is e, so ln must be ln of e, and so on and so forth. Now, the two functions, y equals e to the power of x and y equals ln x, are inverse functions. Therefore, they are symmetric with respect to the line y equals x, because by definition, x equals y at every point there. And inverse functions mean x comma y belongs to one and y comma x belongs to the other. And log x base b, now we're going to go with the change of base formula, is log x over log b. Choose any base, for example, a. Of course, we choose either common log base 10, log x over log b, or natural log ln x over ln b. Example 11, find the inverse function where f of x is 1 minus e to the power minus x over 1 plus e to the power minus x. Let's see how we find the inverse. Number one, change f of x to y just because it makes it easier to work with. That's the only reason. Now, we change the y to x, x to y. And that's right here, the inverse function. We want to solve for y. We do the cross product. X times 1 is x times e to the power minus y, and 1 times 1 minus e to the power minus y, it's just the numerator. So this one, we just write it. X and x e to the power minus y, 1 minus e to the power minus y. Okay. To get rid of e to the power minus y, we are going to multiply by e to the power of y both sides. Let's see what happens. So when I multiply by e to the power of y, this becomes e to the power of yx, this becomes x, e to the power minus y, and e to the power of y is e to the power of 0, or simply 1, that means x. I hope you see the product of these two is just x. 1 times e to the power of y is e to the power of y. The product of these two is 1, so minus 1. This is elementary algebra. I hope everybody's following that. We are solving for y, so we're going to move this, make a negative on the left, and we move this, make a negative on the right. On the left side, we can factor e to the power of y. We get e to the power of y times x minus 1. The right side doesn't change. And so we are going to divide by the parentheses, and it becomes e to the power of y is the right side over x minus 1. And by the way, you can leave it like that, but notice, everybody, this has so many negative signs. So if I multiply the top by negative 1, I get x plus 1. If I multiply the bottom by negative 1, I get minus x plus 1 or 1 minus x. Okay. Now, if I go with the definition of exponentials and logarithmics, and let me erase my work. If e to the power of y is something, whatever, that means y is natural log of that. Think about it. That's by definition of logarithmic functions and exponential functions and the relationship between the two. Y equals ln x means e to the power of y equals x. That's y. And so we give it the name f inverse. So the y changes to f inverse of x. So f inverse of x is ln of 1 plus x over 1 minus x. All right, we want to write this as a single log. Again, we have a lot of properties of logs we should know. So 1/3 ln of x plus 2 quantity cubed plus 1/2 ln x minus ln of x squared plus 3x plus 2 quantity squared. So what do? First and foremost, 1/3 and 3, they cancel each other because this one gets multiplied by that. Then 1/2, okay, applies to this one and to this one. And this 1/2 becomes the exponent for x. And this 1/2 gets multiplied by 2. So this is what we get. Again, I'm assuming we have no problem with the properties. Okay, everybody? So one more time, let me erase my work and show you what happens. Again, 1/3 becomes the exponent. 3 times 1/3 gives you 1. So we get ln of x plus 2. 1/2 of ln x, that means ln of x to the power 1/2. I'm looking at number 7, the power rule. The n sits in front. We go from left to right or vice versa, from right to left. 1/2 sits here, so it becomes part of the exponent. 2 times 1/2 gives you this. Now, these two combine using number 5 as ln of x plus 2 times x to the power of 1/2. And this minus takes it down. First of all, this is square root of x. Secondly, this goes down, but we're going to write it as a factor. From 1, 2 numbers, the product is 2, the sum is 3, is 2 and 1. So ln x plus 2 times square root of x is at the top. And this expression now in a factored format is at the bottom. And we can get rid of that. And whatever is left is the final answer. ln of square root of x over x plus 1. Pretty straightforward, everybody. What about this one? First, we can combine these two using number 5, the product rule, ln of product rule, ln of x plus y times x minus y. Then this 10 becomes the exponent using number 7. So ln of this is at top, z to the power of 10 is at the bottom. What is the product of these two? X squared minus y squared. So ln of this piece is x squared minus y squared. Because of negative, this goes down. What happens here? First, let's put these two together by doing the following. Put this one in here, put this one in here. And now these two give us log x z cubed. And since this is a negative, now we go with the quotient rule. This goes down. We get log of x z cubed over square root of y. I hope everybody is following that. This is something you really should be very comfortable with. We are talking about logarithmic properties, everybody. Expand. Now the other way around. Combine them into 1 or expand them. Obviously, this uses number 5, the product rule. So log of each piece. Log of x plus log of y plus log of z, same base, namely 7. This uses the quotient rule, ln of 9 minus ln of x. This one, log of the top minus log of the bottom. And same base, whatever the base is, happen to be x. Now, we cut this into two pieces, log of x a squared plus log of b to the power 4, same base, x. And this one, 2 sits in front, this one 4, this one 7. And the final answer would be 2 log a base x plus 4 log b base x minus 7 log c base x. This is the same as x minus 1 over x plus 1 to the power of 1 half. We put it in front. 1 half log of the top minus log of the bottom. So again, it has got to do with understanding properties of logs. And hopefully we are comfortable with them. So ln of x squared minus 1 equals 3. Basically, if you're dealing with logarithmic equations and you want to solve them, if you happen to have a number involved, you make all the logs come to one side, number to the other. In this case, you don't have to do anything, but in some cases we come across them. I'll show you. In the meantime, you just go with the definition with this arrow. E to the power of 3 is x squared minus 1. So x squared is e cubed plus 1. And x is plus minus this. Square root of 1 plus e cubed. Or e cubed plus 1 makes no difference. And you really should check if you put plus minus 1 square root of 1 plus e cubed here, because it's squared, it comes out as positive, okay? And then with minus 1 is e cubed, and that works. What about here? First, I want you to notice e to the power of x to the second power is e to the power of 2x. So you can deal with it just the way it is, or you can say, well, if e to the power of x is, let's say, y, z, any variable except x, then e to the power of 2x must be y squared. So if you want to go with that, you can say this is y squared minus 3y plus 2, and say I want to factor it into y minus 1, y minus 2, or just e to the power of x minus 1 times e to the power of x minus 2. It's your choice. If the substitution makes it easy, so be it. So e to the power of x is either 1 or 2. And that means x is ln 1 or ln 2. ln 1, we should know it's 0. ln of ln x equals 1. Look at the arrow. That means e to the power of 1 is the argument, which is ln x. So ln x is e, and then do the arrow again. That means x is e to the power of e. I hope everybody can follow this. E to the power of ax is c e to the power of bx, and we want to solve for x. The methodology for this is to divide both sides by e to the power of bx. And on the left side, using the exponential rule, you get e to the power of ax minus bx, and you can factor the a minus b out. So e to the power of a minus b to the a minus bx is c. That means a minus b times x must be a. In other words, take a natural log. If you take a natural log of both sides, The left side becomes its exponent only, and the right side is ln of c. And you want x divided by a minus b, and you're done. So that's pretty straightforward, everybody. Solve, and we have a bunch of logs and a number. We bring all the logs to one side and together. And so the left side, we are going to use the product rule, and we say it's log base 2 of x times x minus 1, and the right side doesn't change. And now that one side has a single log and one side has a number, we go to a definition, and we go with this arrow again. This arrow, x times x minus 1 is 2 to the power 1. Let me just put the arrow in. Okay. So this is x squared minus x equals 2. Let's take it to the same side for the sake of factoring. We want two numbers. The product is -2. The sum is -1. Would be -2 and +1. X is either +2 or -1. Now, it's important to check. So if we plug in 2 here, that's fine. 2 minus 1 is fine. The arguments must be positive. If I put -1, it doesn't work here. I'm not going to check any further. This doesn't work, never mind the rest. That's out. Okay? So it's important to know. What about this one? We have only logs, so you don't have to move anything around. Each side, bring it into a single log. The left side it is, the right side becomes log of these two, the product of these two. I'm talking about number 5. X times 12 or 12x. So they have the same base, namely 10. They must have the same argument. X plus 12 and 12x must be the same. And x is 12 over 11. And of course, you should check 12 over 11 plus 12 is positive. 12 over 11 is positive, and that's. We can further investigate by actually evaluating it, but ln of 2x plus 1 equals 2 minus ln x, and we want to solve that. To solve logarithmic equations, you bring all the logs to the same side, numbers to the same side. So we're going to move this one and make it plus ln x on the left. Using properties of logs, we're going to combine this into ln of x times 2x plus 1. Now that we have one log on one side and a number on the other, we go with the definition, which means x times 2x plus 1 is e squared. Now, if you keep it as e squared, is perfect because we want to come up with the exact answer. So the left side is 2x squared plus x. Move this, make it minus e squared. And we can use the quadratic formula. Ax squared plus bx plus c is 0. X is minus b plus minus the squared of b squared minus 4ac over 2a. And I want to make sure we know what we are dealing with here. So first and foremost, a is 2, b is positive 1, c is negative e squared. Now we're going to plug in. That's all. 1 squared is 1. This is minus 4 times 2 times that is positive 8 e squared. So Please understand that we have two answers. One of them is -1 minus a squared of 1 plus 8 e squared over 4. And all I want you to notice, this is a negative number. That's all we need to know. We don't even have to know what is equal. It's negative. So it doesn't work. You go back to the original one. Doesn't work here. So this one is out, just the positive one, because this is a positive value, everybody. So there are two answers. One of them is out. You always check with the original equation. In the case of logs, the base and the argument, they both must be always positive. Prove cosine of sine inverse is square root of 1 minus x squared, something from trigonometry, because we deal with everything in calculus. So first and foremost, what is sine inverse of x? That represents an arc, an angle. So we let this one be something, for example, theta. By definition, if sine inverse of x is theta, sine of theta must be x. That's by definition, everybody. Okay? And what you want here is cosine of theta. So cosine of sine inverse, we let it be theta, cosine theta, and this means sine theta is x. We also know Pythagorean identity. One of them says sine squared plus cosine squared is 1. Therefore, cosine is plus minus the square root of 1 minus sine squared. And sine squared theta can be replaced with x squared, everybody. So it's 1 minus x squared, positive or negative, only the positive. Why is that? Recall, when y equals sine x, it doesn't have an inverse. We restrict the domain from minus power 2 to power 2 in order to make it 1 to 1. So we are talking about the fourth quadrant and the first quadrant. In the fourth and first quadrant, cosine is positive. I hope everybody remembers that. Simplify sine of 2 arc cosine x. Well, just like this one, sine inverse or arc sine, cosine inverse or arc cosine, it's equal to something, for example, theta. Therefore, we are looking for sine of 2 theta. And this, of course, means cosine theta is x, right? And this, I hope you remember, is 2 sine theta cosine theta. So we have cosine theta, we can replace it with x, but what is sine theta? Well, sine squared plus cosine squared is 1. So sine theta is plus minus square root of 1 minus cosine squared theta. And this becomes 1 minus x squared, everybody. Plus or minus, we choose the plus. So 2 square root of 1 minus x squared times x. And we put the x in front. Again, why is that? In the case of a cosine, x is between 0 and pi, okay? And the sine is positive in the first and the second quadrant. This is the restriction we put in order for it to be 1 to 1. When you solve exponentials, e to the power minus x squared is e to the power of x quantity squared over 1 over e cubed. One way is, if we could have the same base, we must have the same exponent. If we have the same exponent, we must have the same base. And to do so, if you look at this one, it remains unchanged, but this means e to the power of 2x. This means e to the power of 2x. This means e to the power of minus 3. So that is e to the power of 2x minus 3. So if they have the same base e, they must have the same exponent. Minus x squared must be 2x minus 3. Now, because we want to bring it to the same side and solve it, and this is a negative sign, we're going to move it to the right, make it positive. We want a factor, and we want two numbers. The product is negative 3. The sum is positive 2, gives us positive 3 and negative 1. Therefore, x is either negative 3 or positive 1. And of course, you can check, and they both work. And we are done with this question. All right. What about this one? We want 9 to the power of 2x times 27 to the power of x squared equals 3 to the power of negative 1. They don't have the same base. However, we can come up with the same base. We see that 9 is 3 squared, so this becomes 3 to the power of 4x. This is 3 cubed, so this becomes 3 to the power of 3x squared. Now, on the left side, we're going to add 4x and 3x squared. And because they both have the same base, number 3, therefore, they must have the same exponent. And let me just write 4x plus 3x squared equals negative 1. We get this one. And because 3 is a prime number, actually, it's fairly easy. It's x and 3x. 1, both of them are either positive 1 or negative 1. It's very simple. So x is either negative 1, or x is negative 1/3. And you can check it with the original equation. And it works.